So Chapter 4 is all about plans development, and there's definitely some new tools and new looks of the deliverables that we're going to explore. So some of the basic tools that go into creating the new sheets are a named boundary. Then there's just your typical place notes and labels tools, and there's model annotation that's going to go into the drainage profiles. And then I think you've all had a chance to see the draft FDM 916 for the drainage structures, but the tables are pulling a lot of weight as far as communicating the plan's information. All right, so named boundaries. The tool is found in the drawing tab and has, once it's activated, you have a slew of options as far as what named boundary you want to create. So this is just the first step in before creating a sheet. It creates a view that's specific to a certain range of station or offset or areas of the model. So for the drainage sheets, there's large format, 36 by 48 up to a 36 by 72, or you can stick with the 11 by 17s. And there's a manager that will list all of the named boundaries that are present in a file or attached as a reference to the file. So I mentioned named boundaries will create a view. They do that, but they also create another model in the design file. So this is a snapshot of what it would look like once a named boundary is placed for a plan view. You can see there's a drainage plan 1 and a drainage plan 2, as well as a drainage plan 1 sheet, and likewise plan 2 sheet. So as we go through the examples, we'll explore what that looks like, how they're interrelated, and there's possible discussion on moving this plans production workflow outside of the design file into a separate sheet so that multiple users can get in there and work at the same time. There's other view tools that will help with the plans production side, specifically if there's special details or isometric views that you want to add to a sheet. There's a tool to create that view so you don't have to work to recreate it, and it'll be there as a reference option once you get the sheet created. The annotation and labeling tools are pretty similar to what we're used to in the past. What has changed is the content that we're asking users to label in the plan sheets. All of the profile information related to drainage is going to be automated, but there will be the need to label on occasion the existing ground, proposed grade, utilities, that sort of thing. In plan view, we're only going to be showing the structure number as well as the pipe name, and that'll be the primary link to the tables that contain the actual plans information. So these labels are dynamic, and let's say you change a structure number from 101 to 105. It's ideal if we can get those to just update automatically. That's what we're aiming for on a lot of this production resource. So to do that, the text favorites has been developed so that these labels are dynamic and it's based off of the element information. And model annotation, that's what's going to be used in the profiles. And if you're familiar with geopack drainage and how it may have automated some of the profile labels back at that point, it behaves pretty similarly. It's automated, it can put in a grid, but it's not really editable, or the edits are harder to maintain. It can be wiped out in one file swoop and added back in as needed, but it's pretty hands-off, particularly because we're not trying to provide a ton of drainage information in the profiles. And lastly, tables. We did see one little excerpt of the storm tabs back in Chapter 3, but there's other tables that have been developed, flex tables, specifically for plans. So we've got a set of 3 different tables, one for pipes, one for structures, and the other for invols and MESs. So the general workflow is to export the flex table from OpenRoads into Excel, apply some formatting, and then place it back into the sheet as a static table. Some of the other pieces behind the scene that are helping our tables get populated with standard plans information are user data extensions. So a lot of it is a Bentley custom property, or sorry, a standard Bentley property, such as locations, station offset. That stuff's easy for it to define. It's a little more difficult for it to know what the standard DOT structures are. So you've got how you would want it to be called out as a curb inlet type 9, 10, etc. So those are now pick lists that users can select so that the tables will be populated automatically. All right, so that's the quick overview. Any questions before we jump into some exercises? And I think at this point, if people want to try and follow along again, we'll go slow through these steps and creating sheets and such. So if you want to take a chance to download the DRPR _3 DGN, that's what I'll be sharing screen for. All right, no hands. Let's go ahead and get started. So in the drainage and utilities workflow, we're going to go over to the drawing production tab, and towards the right, there's the named boundaries group, and we're just going to click the icon at the top, and that generates this window here for placing a named boundary. At the top of this menu, you can hover over the different icons and it'll show you what type of named boundary we're going to select. We are going to stay on the left side with civil plan, but you can see there's a plan by element, a profile, cross sections, and so forth. So we're going to fill in from top to bottom. We're going to do a drainage. Let's do a drainage plan at 36 by 48. Now this size might be overkill for this 3-structure system, but it'll give you a feel for how the space could be filled out when there's more network elements involved and how to stack profiles and such. So 50 scale, that works. We don't really need to rename the default plan. And we're going to continue down, filling in the, I guess we do need to name the plan. Okay. So if it dings at you, rename it till it's done there. Call it drainage. drainage plan. All right, it's going to be a new group. I'm going to call it drainage structure sheet. It doesn't have to have a title or description. So the next pieces are going to, actually I think I need to turn on back on my references. If your files have them off, you can turn them back on. That's going to help us as we're setting our sheet limits here. So if you select the center line, easier to grab from the beginning there, it recognizes the stations and gives you an opportunity to customize the station limits. We don't really need the sheet starting at $6.99 plus $89 at the beginning of this profile, but our sheet's big enough it probably doesn't hurt. If you wanted to customize it and snip it down, these tools will let you do that. The arrows to the left and right, they'll lock it to the beginning or end of that alignment element. So if you left click, it's going to give you a preview, and it's pretty faint in this window, but there's a red dash line that's now got these tentative sheet cut clips. And I'm going to continue to click left to accept. There we go. So you see it's populated a little bit more clearly now. So the next window that pops open is all about cutting the sheet. And I think all of these settings are just fine as is. We'll do a little bit of changes once we pop in the profiles. But for plan, we can just hit OK. So we'll let that process, and it now has moved us into the model for Plan 1 drainage sheet. I think we've got a couple sheets. So when I gave it that range, I said just do the whole alignment. So it ended up cutting 2 sheets. So our system is going to show up here. And something to note, it kind of behaves like a parent file in the old MicroStation Geopack sense. It should behave if I were to go back to our model and turn on or off references that maybe I don't want to show up in the file there. Let's say for some reason I wanted to turn off the pond. It seems to be hit or miss whether or not it maintains that kind of live connection, but it did here, so we're in good shape. So looking back at these models, before we did the named boundary, we just had the default 3D views and multi-model views. Now we have 2 sheet models and then 2 view models. So it's this is the middle step between what's being referenced. It comes into here and then it's put into the sheet. And I'll further demonstrate that by going to the attachments in the sheet model. So you can see it's looking for that Plan 1 drainage model. So that's this, and this file is looking back at our default model. All right, so now let's move back to the default view, and we're going to create a profile named boundary. So in our profile runs, there's the S103 to S102. I'm going to right click, open profile model, and it's asking to put it into a view. I'm just going to pick view 7 for no particular reason, but now I've got a window with this profile in it. And you can see now the HDL is populated now that we've run a compute. So we're going to go back to the named boundary tool with the profile view active. And instead of civil plan, we're going to go over to civil profile. So our drawing seed is still going to be this 36 by 48 drainage. And let's just click on bottom. So the different seeds, I'll explain where those come in, but it helps the stacking of the profiles as they get placed. But even if it comes into a spot that you don't like, it's a reference that can be moved and relocated. All right, so no settings need to change so far. Going down to station limits. So we're going to click in the View 7 window. And then with that active, click the arrows to the left and to the right. So you can see it's recognizing the station limits that are in the profile along the length of the pipe. But we want it to show a little bit before and after because we want it to show those structures at the end. So I'm going to hard code in a -20 here. And same thing, I'm going to hard code in just an even number there. Never hurts to just do the math to see the total length from -20 to station 2 plus 20 is 240 feet. And then no further changes to the input are needed. So if you go back to the view of the profile, now it's showing you, got to click once, I think. Let's see. There we go. There's the red dash showing you where that sheet cut and that view is going to be saved. So left click to continue to accept the prompts. There we go. So now the window pops up again for create a drawing or cut a sheet. So this is where we don't want a new sheet. We want to put this on the drainage plan sheet that we've already created. So no changes till we get down at the sheet model section. And we're going to put this in the first sheet, the one without the one, where our plan view is shown. And then hit OK. All right, so now we see we've got our grid pretty well lined up in the sheet. So when we selected the bottom drawing seed, that's what it meant. There's a bottom, a middle, and a top row for these kind of default profile positions. But if I wanted to relocate it, it's a reference that can be moved. All right, so I do see we've got a little issue with the structure bubbles not quite populating automatically. But just for reference, everything else that's shown, we didn't do any labeling. This all came in automatically. So similar to before, there's the sheet model, but then there's also the profile view that gets created with a named boundary. And here's where we're going to kind of demonstrate the model annotation tools. So over in the drawing production tab under the annotations group, there's model annotation. So we're just going to click remove and left click through the prompts that are basically telling it just this model is what we want to remove. So there you can see our grid is gone, the pipe names are gone, the structure names are gone. And to put it back, Same process, left click, and here we go. So I think there is some little bug about the structure bubbles that we may have to put in a tip or trick about. But let's come back to that because we can get to it with the plan view labels. All right, so following along, I think we've finished up 4.2. Not quite. Let's, we'll place our label for the existing ground here. So under the place drawing production notes group, place note tool, this is just freeform text. And you'll probably want to set up FDOT dim as a dimension style there. So I'm going to type in existing ground above pipe. But I probably first need to double check. I don't want it to go onto default. I want to put it on a text level. So I am now back in the Home tab. Under the attributes group, there's the active levels. And I'm going to just restart that so it's on the newest setting. It should. All right, so maybe not the quite right dimension setting there. And it came in on dim lines. Well, that is technically right. Let's see. FDOT nib, I think I picked the wrong dimension level. Let's try that one again. So I'm just going to delete this note. Oh,
in the text editor, by changing the style in the text editor to FDOT.
There it is, yeah.
It's still not changing it. Okay, well.
Yeah, not sure why it went on, didn't follow the text label.
That's a change level thing, but it usually comes in right. I'm not sure what's going on with this one.
Hey, Bern.
But, yeah.
Set your level, then restart the tool is what you'll have to do. It's just a workflow thing. Set your level first, then go to the text editor. It should change.
Yeah, no, thank you. I thought I tried. It must be going crazy. So it's active here, text label, and I'll place note. All right, well, some things for us to take a look at after this. So there are some manual labels to add, and what we haven't done yet is we only see existing ground. We want to show proposed too. So we're going to go back to default, and we're going to put our profile back in the profile view there. So repetition makes us experts here. Open profile model, click on that view. Here we go. I think I also want to see the 3D view at the same time. So I'm going to go to View, 3 Views, Plan Profile 3D. And then I'm going to put this profile back in here. All right. So to populate the 3D terrain information, I have that turned on. There's tools in the profile model at the top, and there's one for quick profile from surface. So this will help add anything that wasn't on there before. Oh, there we go. So now we see it. So the idea is once it's triggered, once the prompt is up, to select the reference, click on the outside edge of the DTM top mesh, and then it will populate the proposed profile along the pipe. And so this cuts off at our second inlet in the run, which makes sense because we're stubbing out into a pond. So let's try and add that surface as well. So again, quick profile from surface, clicking on the edge of the pond and then accepting. So now we see the top of the pond, berm, and the slope down. The other feature of the profile here, we're only showing kind of the cut inside the pipe. If we wanted to see the 3D cut and see a little more accuracy in the structures, the Create 3D cut is our tool for that. So that's the second from the left in the top of the profile view. So that prompt is basically, well, the method, we've got a couple different methods, whether you want it to be corner or full profile. If you do a corner, you just drag a window across where you want the 3D cut. So let's take a look at, so now we see a little bit more detail into, there's the manhole that's on top directly above the pipe. But it also comes with some baggage. So now we see all these pipes that appear to be laterals coming in, but that's just the representation of that one pipe along this length. And now you can see we've got a little bit more representation of the slope of a mitered end, whereas the 2D is just always going to be a rectangle. So once you're done with it, you can just delete the cut, and we're back to just the 2D elements. So now I'm going to check back into our profile view and add some labels for, I'm going to move this one and edit it to be for our proposed grade. We'll start fresh. All right, place note, proposed grade. Oh, that worked. Now we're on text level, text label.
Maybe you had to get out of that view, set the level, come back to that view. And then
All the tricks. All right, so then we go back to the sheet. Then our new labels have shown up. All right, so I think that is the extent of profiles. We will cycle back about the structure bubbles. But next, let's just go to labeling in plan view. So designers may be choosing different methodologies for whatever's best and most efficient for their projects and management of those work efforts. I'm just going to turn off the 3D file here. So in this case, our examples, we're putting in the labels in the default model, but that might not be the preferred method. I would say what could be useful in here is most roadway files or other sheets are going to reference this, where the basics of the structures are. So having labels, structure labels already there for them could be helpful. All right, so in this case, we're going to use a different tool for the labels, except first we're going to orient ourselves so that when we place a label, it's going to be horizontal on the sheet. So I'm going to flip back to our sheet here. You can see north is not up, which we'll add a north arrow back in our model so we can make sure we're aware of where we're at. But by opening the references, we can see that our plan view is rotated this 134 degrees. So I'm actually just going to copy that number because that I think will be useful in getting us separated. It's a little more complicated, and maybe we'll look out. The clips of the named boundary are here, but sometimes if there's curves, it's not just a straight line and it can get a little confusing. So I'm going to go to Rotate View and just pick the edge of the named boundary there. So now, actually that looks pretty good. You don't have to worry about doing any special rotation, but there's some tricks in the course guide if there's any other questions on how to find where is my sheet cut at. All right, so from the Drawing Production tab, Notes group, the Place Label tool is what we're going to use to put in the structure numbers. And we're going to use a cell, and there might be a little bit of a trick to getting our cell to populate in this list. It has the ability to reference all of the cell libraries, so it's quite a list, and not exactly the ones that.
But I think we started the label for those with Sue in there, maybe. Oh, for the cells, never mind. I still think it is a Sue cell, SU underbar something.
Yeah. So if it's not in the list, I think there is a, let's see if we get it to come back up again, like an underscore Sue maybe. Opening the cell library seems to be a troubleshooting trick. All right. Oh, there it was. Come back. Underscore Sue node ID is what we're looking for. Here we go. And we're going to change the dimension style to FDOT dynamic labels. And instead of, we're going to go with the version without a leader. And just to double check, oh, now we're on construction lines. I'm going to set our active level back to text, text label. All right, so now if we place this, it should come in on right. We can always change it. All right, so it's looking for select a point location. Really what you want to do is just click on any part of the node. And now you can see I've got this range of locations to populate the structure number. And you can do that remainder of these same way, just clicking on the node, and it automatically populates the structure number. All right. Now it's a little different. Actually, it might be the same tool that we use, just no bubble for the pipes. So instead of a cell, we're going to go back to the type, and from the pull-down menu, select text favorite. So our labels are under the underscore SU, and we're going to be labeling a link or conduit. So that should be the right settings there. All right, so again, just click on the element, and then it'll offer you a place to place it. I've had not a ton of success getting it to automatically align with the pipe, but I suppose if you were to rotate your view, which I'll do here, like that, and then you used the place label tool, it would come in. So I'm sure there's tricks people can use. No leader. But once it is placed, it can be modified, moved around there we go, to avoid any crashes. So let me go back and rotate. Actually, I want to throw a north arrow in there while we're here. So under our drawing and cells, drawing tab, under the placement group, this is pretty similar to Legacy MicroStation. Oh, you can't, it's off the screen, but I'm going to go to the roadway cell. And this north arrow plan scale will automatically populate the scale that the sheet's cut. So I think, well, here's our sheet limits. I'm going to put it in the upper right. So now when we go back to the sheet view, there's our north arrow. Here's our structure labels, pipe label, are all showing up. All right. Any questions so far? Everybody able to follow along okay?
I got a question. I know you're doing profiles right now. Right? Is there any exercise that we're going to be doing cross-sections?
There are no cross-sections. The FDM 916 drainage structure sheet has a, I'll see if I can pull up the draft of the PDF that's under review, but all of the content is plan view kind of in the upper left, these profiles in the lower left, tables on the right, and any special details in the upper right. So that is a good opportunity. I'll bring up the PDF. I think this is the latest version I have. There might be updates out there. So plan view upper left, profile cuts along all the pipes lower left, any special details, utility conflicts, whatever is project specific that's not already covered sufficiently between the plan view profile and tables. So the drainage structure cross sections that are usually, well, in the 300 series of the FDM have been replaced by the tables that have the same information, just represented a little differently. But we'll be getting to the tables next, if you want to see those in more detail. All right.
Just one quick question before we move on to tables. Was there an exercise for the to modify the annotation group information anywhere?
In the profile annotation group, or
Yeah, if you go back to the multi-model or the default view, it'd be worth just to show this to them. If you go to the standards and then in the file there's the annotation groups, and if you notice that anything that got automated, like if you right click and manage there, that is all the information on the left right now that we're placing on that profile. So let's see, for the points, yeah, that's where we would have seen those circles. See the bubble right there? For some reason it's missing. Well, I'm not sure what it is, but that's maybe the Sioux bubble profile isn't there or something. I'm not sure, but that's what would have done that.
right.
And then I did upload a north arrow for the plan setting. If you go to the plan annotation group and go in the just a linear roadway and then that baseline plan, you right click manage there. You can import other annotation settings. Like you notice that this list in your, I mean, we have a north arrow now associated with these, but you can always import one. At the top, there's a bunch of icons. The farthest one to the right is import, or that's export. There's an import XML. So if you look in the managed materials, I actually have one out there, but you would need to delete the annotation that's in the plan now and then add this and then go back in and add the annotation. But yes, that's a way to add other annotations if you don't already have them and you see them on somebody else's file or something like that. So all of that stuff is set up in here as far as customizing what gets automatically drawn on plan and the profiles.
Yeah. Thank you.
Yep.
All right. I think we're trying to now get to placing some tables. But first, I think we're going to export some. We'll probably have these already in the data set, training data set. But for our purposes, I think it's still a valuable exercise here. So in our default model, in the drainage and utilities, under the analysis tab, is where we have the flex tables. And there's two tabs in the flex table manager: subsurface utilities and hydraulic analysis. And I kind of just summarize, subsurface is more of just the locational type information, where hydraulic analysis is really where the bulk of our data and model information is stored. So we already looked at the storm tab, but we have this set of plans tables, each of which require a little bit more input, and I alluded to some pull-down menus, so we'll get into that. So if you open the FDOT -CB or catch basin top bot, so the top and bottom information, double click to open. It sees that we have two catch basins, and based off of our feature definitions, it's already populated the typical top, name, and bottom. But what it didn't see is when we made our J bottom, it won't change that. So we need to change our type 2 J bottom from a 4-foot diameter to 5-foot diameter. And if there's any notes that we want to put, and I'm just going to populate this for clarity to see how it works. A typical note that we'd want for a curb inlet. Well, we'll just put in some test notes. And remarks, those are both options that'll get populated in that other larger structure information table. So we can close that out. If we had manholes, we would go through the same exercise. Open roads, from a database perspective, separates out different types of structures. Catch basins and inlets are all in one group. Manholes and junctions are in another. And even like mitered in sections would either be a head wall or an outfall. So there's different tables that get produced with those, but we can merge them together for purposes of plans. So from that same FDOT CV top bottom, I'm now going to go to the FDOT plans CV. So all of this is in yellow, meaning we can't edit it here, but our changes from the other table are reflected. And sometimes the link can get lost, and it's probably more likely that I didn't set that second structure for the baseline feature. But this is a good view of what happens when you forget that step. In order for our plans tables to populate the station offset information, we have to go back into, which I'm going to do right now, into the properties of the structure and make sure this station offset reference is set to our alignment. So now if I were to go back into that table, there we have our station and offset. From here, I'm going to export. So at this point, it becomes a static snapshot, not dynamic table. But it's the best version of what we've got to date as far as how we're going to approach plans development. So it first exports as a CSV file, and it's going to just the engineering data folder. And I'm going to hop back to that folder with the Explorer Directories trick. There we go. I'm going to open this in Excel. Excuse me. So this format's also a CSV is not compatible from a place table standpoint, so we're eventually going to have to save it as an XLS. And in that same process, we can update the formatting. So just by selecting the populated portions of the table, I'm going to do a few formatting changes to find the FDOT font. I'm going to give it some borders. I'm going to do like the rep text. Make some adjustments on the column width. And delete these stragglers of none, which you could also do with the find and replace. And I think I'll also add just a column or a header here for structure data. That FDOT font. All right, so I'm going to save as Excel sheet. So the formatting should be preserved, and it could obviously be cleaned up a little bit more, get the decimal places out to the right spot, maybe throw some center alignment, what have you, but this is the general idea, general approach. Okay. So once it's saved as an XLS, we don't need the CSV anymore. And close out the flex tables and go over to our sheet. So generally we're going to place tables in this quadrant over here. And the lines are live. They can be removed if that's the designer preference. So back into drainage and utilities and into drawing production. Towards the left is place table. So when you click on that, you have three options at the top. You can just do an empty table, from a report, or from a file. So we're going to select the Excel icon, and under the file name, the browse ellipsis, we're going to find the Excel file we just created. And it helps if you check some of the boxes beforehand, if it contains a title row or a header row. But you can see the next window that prompts up, it automatically searches for content in the spreadsheet and suggests a range to report. If you wanted to change it, there's a manual option as well. So right now it's thinking. It'll bring up a little processing window there. Yep, generating table. And then at my cursor, it'll place. Not sure how consequential it is, but the checkbox, we did add a title row, and there's headers in there as well. So that gives it a prompt to reprocess that table once more. And I'm just going to line it up here. So now when it's placed, there's a Excel icon on top of it. I'm going to select the table, and then you can see the ribbon automatically changes and adds this Table Tools Layout tab. So if I wanted to do further editing to this table in MicroStation, there's a slew of options there as well. All right, and let's see, let's just go ahead and clean this up one little bit. So you can see how it'll make the change live in the file. So in total, there are, depending on the network, just a few tables that need to be imported. Pull this PDF back up. And there are flex tables for all of them except for the optional materials tabulation, which is, I guess, for some reminder or clarification how we're handling that. The pipes have a data field to select a group number for the optional pipe that it's associated with. And then there's going to be a separate table that clarifies, well, what does group 1 mean? Okay, it's 18 to 24-inch pipes with these particular materials. So that way the database is somewhat up to date as far as what the intent of the design and material is. But it's also more concise than having a user pick all of the options, or just think of adding 10 columns to this pipe data table with a yes or no on this material or what the gauge number is. So this was a more simple way of handling that amount of data. But the pipe data table, which is the upper left here, is the flex table that gets populated. The structure data table is what we just placed. And the invol and MES data table is there as well. So I'll go back to those flex tables and just show you what they look like. And just as an FYI, the flex tables are not available if you're in the sheet model. I can hit the button, but it's all grayed out. So we've got to go back to the default. And then the flex tables become able to open. So our plans pipe table is really automatically populated. If for some reason you wanted to make edits to the inverts, if it's a white cell, then you can edit it. So let's say I don't like this 2650, I want to make it 2660. That is an edit that's carried through, and it took a second to process, but now that change has been made. So flex tables are another way of making changes, and perhaps in bulk, because it's got this database tool and functionality where if I wanted to do a global edit, I'll set all my inverts at a certain elevation, or for whatever reason. If it's easier to edit things in bulk, that is an option instead of just clicking side or pipe to pipe to pipe. And I think the last table for plans is the MES invol and outfall. So RS-102, again, it seemed to have lost its reference, so we can fix that real quick. Should be there. Sometimes it needs a little encouragement. There we go. Well, almost. There we go, 70640. Okay, so clicking on them, refresh it. So in this case, we don't have a structure type automatically selected with the feature definition. We said this was a 1-to-2 cross-strain MES. And we could put in notes if we wanted, but those are basically the tables. Could be a good time for questions. I'm just going to double check the chapter exercises. Yep, that is the end of chapter 4.
There was one question Miranda had in the chat about when you were changing the size of the bottom from 4-foot diameter to 5-foot diameter. This is something that that we'll need to perpetually do, or if it's something that can be automatically done in the workflow.
So what's automatic about it is if it's standard, it came in just fine. But since we did a J-bottom, it does require, let me get back to that table there. There is just this full list of all the available bottom sizes, and that is something that users will need to verify is what they want built. And
So even if they built let's say they built a feature before they placed, or maybe when they placed it they changed it. Is there a way to set it somewhere else before you get to this stage if they were to just place that feature that
yeah,
way?
there could be. So what that is being populated as is a user data extension, and I'm just going to open up where that list is defined. So the available user data extensions to catch basins, this FDOT bottom is the one we're talking about. So this is where the list gets defined, and if for some reason somebody wanted to add or add one to this list, that could be a place where they do it. And then the feature definition is where that user data extension gets applied automatically. So when we created this JBottom, what we could have done is in the user data extensions, given it a default value. So under the feature definition, it would have been, oh, I get this, the top. So the bottom would have been this 5-foot diameter, and then it would have come in automatically. When we placed.
Excellent.
So
I think that answers your question.
Okay. And that's probably a valuable thing, especially if people don't want to have to repeat it. We can add that to the example instructions for adding a JBottom to point that out. But there's actually the next chapter. This is a good segue. We're going to get to other pick lists where you do similar things as far as making assignments so that the pay item is correctly identified.